So we are dealing with instability problems governed by differential equations with variable coefficients. And this topic naturally is governed by the following differential equation: d2 dx square ei d2w dx square plus p d2w dx square equals 0. But if the column is simply supported, then we can deal with second order differential equation. ei w second derivative plus pw equals 0. And then we had two cases, okay? Considered one by Zhanitsin, by Duncan, and Zhanitsin, 1955. So Zhanitsin says EIX equals EI0 4x L minus x divided by L square, and the appropriate buckling load is eight EI0 over L square. In Duncan beforehand, he had EIX equals EI0 1 minus 3/7 x over L squared. And here he got 60 over 7 EI0 over L squared. Whereas Euler, so here we can add additional EIX is not constant. And here it's constant. Euler actually has EIX equals EI and is constant. And he obtained pi square EI over L squared. This is one. We, I think, missed some students, is it right? Mr. Plasencia, Mr. Berezhnoi are missing. Now we said that Duncan and Zhanitsin solutions give rational expressions. Okay, numbers are rational. Rational expression means that P critical can be written as M over N, EI0 over L square, where M and N are integers. Okay? Now, irrational expression, say pi square EI over L squared irrational, because pi cannot be put as m over n. It can be approximated. I think 3 in 1/7, which is 22/7. And this is, I think, 3 and 10/71, which is 221, 22, 4 divided by 71. Okay, that is done by Archimedes. So that could be only approximated. So lower bound and upper bound are rational expressions. Okay? So pi can be written as we know. Do you remember the mnemonic rules, how to remember pi, the numbers? Okay, that I think it's like this. Can I have, or may I have, a large container of coffee? So here we count 3 letters, and 1, 4, 1, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 1, 2, 3, 4, 5, 6. So please, when you drink coffee, remember pi. And every time you deal with pi, please remember coffee. There is another longer expression. I will bring it next time, but it starts like this. How I want a drink. Okay, so that is what, 3, 1, 4, 1, 5, yes? Alcoholic, of course. So that is what? 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 1, 2, 3, 4, 5. So, no, 6. Yeah, because, okay, so this coincides with that, yes? After heavy chapters of quantum mechanics. Okay, so if you want more digits, so then you should think about quantum mechanics rather coffee or alcoholic drinks, no, not coffee. So that is how to remember pi. Naturally, now we know pi up to, I think, 1 billion digits. Okay, we know first 1 billion digits. If you want very precise value of the buckling load, then of course you can just tell the person that, wait a minute, I will now give you first billion digits after 3, okay, in pi. But still, this is an approximation. Okay, whereas Zhanitsyn and Duncan give exact closed form solutions. I mean, let us say closed form rational solutions. Now I had a thought. Are there out there only two rational expressions for the buckling load? What do you think? That is a question that I had. We know two solutions that I reported to you. And my lecture notes give you these two solutions. They report this to you. My question is, are there more solutions like this or not? What do you think? So we have 4 people present. Let us start from the left. Why not? Okay. So these are the questions that I asked myself and came with the following considerations. Okay. First of all, mode shape in both cases was polynomial function. Okay, that is, so W Zhanitsyn was what? W Zhanitsyn was 4x L minus x over L square A. Okay, then W of Duncan was 7 minus, 7x over L minus 10x over L square plus 3x over L. No, that was not square, but cubed, sorry. In 5th power, A. Okay? Now, I thought that how can we get polynomials? Polynomial functions. Okay, so that is a question. So I thought that, look, let us start w of x equals, say, b1 plus b2x plus b3x squared plus b4x cubed plus b5x in fourth power. That is a polynomial of fourth degree. Do you have any questions at this moment? No questions? You should have a question. I mean, asking a question is not a choice, but a must at this point. Speak louder.
For the other cases, we have sine, cosine, sine.
Okay, Ms. Gentilini says that for other cases we had sine and cosine. Yeah, but we are not talking now about sine and cosine. We talk about polynomial functions now. Now we are concentrating. In these two cases, there are polynomial functions. So we anticipate that if there is another solution like that, theirs, then maybe there should be a polynomial function. Okay, so therefore we say, how can we get polynomial functions? That is a good question to ask. So I'm answering, okay, let me write down polynomial of fourth degree. Actually, I better have written here b0, b1, b2, b3, b4. Okay? Now you should have a question. Mr. Andres, what is the question? Okay, how we find coefficients? Okay, boundary conditions we have to invoke. Another question. Mr. Gomez, what is another question? Okay, Ms. Gentilini, you had a question? How is a column? Column fills well. You ask me how is a column? Column is okay. I'm talking on behalf of the column. I'm a column's representative. Column is okay. She asked me how is a column, okay? We don't know yet. I'm not asking still. I'm very far from this question. Flexural rigidity. Forget this. First, I'm talking about what I'm talking. And that means that I'm not talking about anything else. Paying attention. When I'm talking on some topic, that means that I don't talk about any other topic. Okay? We want questions about what we are talking about. Okay, another question is why fourth order? Why did not I continue further? Why did not I stop before? Is it right? So what is an answer to this question? Okay, this question we have an answer, yeah, boundary conditions. What about this? Okay, because we have 4 boundary conditions. And we suspect that if I want to satisfy 4 boundary conditions, maybe fourth order I should take. We will check later, maybe we can take less. Okay, let us see, maybe we start start with third order because fourth order coefficient system has 5 coefficients. So okay, maybe we will start W of x equals b0 plus b1x plus b2x squared plus b3x cubed. Let us start with this. When x equals 0, w at 0 should be 0. From here, b0 is 0. Because I substitute 0, 0, 0, so this must be 0. Because if b0 is not 0, then w does not become 0 at 0. Yes? Now let us calculate first derivative. It will be b1 plus 2b2x plus 3b3x squared. Now calculate second derivative. It will be 2b2 plus 6b3x. So w at second derivative at 0 must be 0, yes? So b2 is 0. Now, that means that I will rewrite w of x. b0 and b2 are 0. So this is b1x plus b3x cubed. Then, w at L equals 0. We get b1L plus b3L cubed equals 0. But then w second derivative at L equals 0. Second derivative is from here, yes? 2b2 plus 6b3L equals 0. But b2 is 0, we said. If that is the case, then b3 is also 0. If b3 is 0, then this is 0. Then b1 is also 0. Then everything is 0. Okay? So if we take third order polynomial, then it must be 0. Okay. No, that's 6. And now we go to the fourth order polynomial. W of x equals b0 plus b1x plus b2x squared plus b3x cubed plus b4x in fourth power. W at 0 equals 0, so b0 is 0. Now we calculate derivative. b1 plus 2 times b2x plus 3 times b3x squared plus 4 times b4x cubed. Second derivative. 2 times b2 plus 6 times b3x plus 12 times b4x squared. Okay, we remember this. Now, w second derivative equals 0 at 0. Therefore, b2 equals 0. So it's the same, like we got before. Now I'm just rewriting. W of x equals b1x plus b3x cubed plus b4x in fourth power. So w second derivative, I'm just writing b2 is 0. So that is 6 b3x plus 12 b4x squared. Now, w second derivative at L must be 0. So 6 b3L plus 12 b4L squared is 0. So let us express B3 from here. B3 equals minus 12 over 6. It is 2 B4L. So we substitute this here. And we get W of x equals B1x, B3, minus 2 B4L x cubed plus B4x in fourth power. Now W, second derivative I don't need. Now this should be 0 at L. B1L minus 2 B4 L in fourth power plus B4 L in fourth power equals 0. From here, B1L equals, this is 2, minus 2 plus 1 is minus, so it is B4L in fourth power. So B1 equals B4L cubed. So if that is the case, then W equals what? W of x equals. B1 is B4L cubed x minus 2 B4L, I'm just rewriting, x cubed plus B4x in fourth power. So B4, we have here B4. B4 is an arbitrary constant. Let us put it 1. You know what? Let us put it, I will not, 1 over L in fourth power. So W of x will be something like B4. And we have x over L in fourth power minus 2 x over L cubed plus x over L. And this B4 is, imagine, 1 centimeter. So then W of x equals x over L in fourth power minus 2 x over L cubed plus x over L. Okay? So that is a fourth order polynomial. Comment. Thank you very much. But what should we do with this? So we got this fourth order polynomial that satisfies boundary conditions. What should we do with this? This polynomial does not appear, is it right, in the list of Zhanitsyn and Duncan. Look, Zhanitsin has second-order polynomial because it deals with second-order differential equation. But Duncan has fifth-order polynomial. So we have fourth-order polynomial. So fourth-order polynomial does not appear in that list. So do you have any questions or comments? Mr. Penteras. Speak louder. I see. Okay, Miss Gentilini. Yeah, okay, so no, we did not solve any problem. We just put some polynomial and then we satisfied boundary conditions. So this does not have any connection with the column. I just put any polynomial out of the blue. Is it right? Like in circus, you know, you put your hand in your pockets. You put here, circus person puts hand in the pocket and brings polynomial out, or chicken or egg sometimes, and then he throws it or something like that. I should have brought live chicken maybe, and then I would say, oh, that is a fourth-order polynomial. Okay, so what is the question now? We can still ask some, look, please. To provide answers is very difficult, to any question. But to ask questions is very cheap, actually. Is it right? You can ask a million questions. You can ask such questions that no one will answer, not even all the Nobel Prize winners together. But asking questions is very easy. Okay, Mr. Andres. Okay, if you plot it, looks like beams. It satisfies all boundary conditions, so it goes like this. Yes, I'm very sure. Any other questions?
Does it satisfy the governing equation?
Yes, of course. We wrote some function. But what is the connection of this? We just wrote some function out of the blue. The question is there a possibility that this function, that nice function, is it right? It is a nice function. There is no sines, cosines, there are just x's. Is there a possibility that this function will satisfy a differential equation? So what do you think? What are the possibilities? Yes. No. Please look here. Ms. Gentilini put many possibilities here. Yes, no, I don't know. She just said in one sentence, yes, no, I don't know. Okay, so let us continue. So we have this differential equation. d2 dx squared ei d2w dx squared. Oh, actually, it's plus p d2w dx squared equals 0. Or we have a simpler case, because that is a simply supported. EI d2w dx squared plus pw equals 0. Is it right? So we can actually ask as follows. Is there any EI as a function of x such that w that we wrote before is a buckling mode? That means satisfies boundary condition, satisfies this differential equation. Now, let us think together. Look, please. W is a fourth-order polynomial. Now, here also W is a fourth-order polynomial. This is which order polynomial? Second. Because W is fourth order. When I differentiate once, it will be third order. When I differentiate again, it will be second order. So what kind of polynomial should be EI to satisfy, to at least orders to satisfy? What order polynomial should be? Again, this, we deal with this. That is a fourth order polynomial. That is a second order. What kind of polynomial this should be so that these together will be fourth order? Because this is a fourth order polynomial, and we want this also to be of the same order. What this should be EI? Second order. Okay? Allow me to denote it by the same coefficients, if you do not mind. EI, first of all, we denote as d of x. And then b0 plus b1 x over L plus b2 x over L square. Let us denote like this. Or actually, we don't need such a notation. Let us denote it b0 plus b1x plus b2x square. Now, what happens is as follows. Look, please. So W of x equals what? X over L fourth power minus 2 You know what, maybe we put W of x in a not non-dimensional manner, but we will write as follows. On page 8, b4x, no, not before, L cube x minus 2 Lx cube plus x in fourth power. So let us put this in this form. Okay, because that is easier to deal with us, with this. Now then EI is this polynomial. Then W prime first derivative will be L cubed minus 6LX squared plus 4x cubed. W second derivative will be minus 12 LX plus 12x squared. That is a second derivative. Now we want to calculate EI, W second derivative. How much is this? EI itself is what? From here. B0 plus B1x plus B2x squared. And this is multiplied by minus 12LX plus 12x squared. Yes, I'm just multiplying. So what I'm doing is as follows. I found that EI should be second order polynomial, so that first expression to be polynomial and second expression to be polynomial. So I'm now substituting this B0, B1x, B2x squared. And that is a derivative. I will just take minus 12 out of there. 12 will be B0 plus B1x plus B2x squared minus LX plus x squared. And I will start to multiply. 12. This term first by every term. Minus B0 LX and minus B1 LX squared. Then it will be minus B2 LX cubed. Now I'm multiplying x squared. Plus B0 x squared. Plus B1 x cubed. Plus B2x in fourth power. Okay, I put one under another so that squares are together cubes. So that equals 12 minus B0 LX and plus B0 minus B1L x squared, then plus B1 minus B2 B2L x cubed plus B2x in fourth power. Okay? So that is a product. This is L here. Now I want to add to this plus PW. What is PW? W is here. So PW equals P times L cube x minus 2LX cube plus x in fourth power. So if this equals just PL cube x minus 2PLX cube plus PX in fourth power. So now I have to add these two things and see whether they work together or not. 10, now I'm writing 11. I'm putting this and this together. So I see, look please, 12 minus 12 B0LX. Please pay attention because I may well make a mistake. 12 B0 minus B1L x squared plus 12 B1 minus B2L x cubed plus 12 B2x in fourth power plus PL cube x minus 2PL x cubed plus PX in fourth power, that equals 0. Please derive U2, I mean if that is correct or not. So I'm writing down then minus 12 B0LX. Now I will combine all, okay, sorry. This term and these terms should go together. So that is minus 12 B0L plus PL cube times x. Then there is x squared plus 12 B0 minus B1L x squared. Now x cubed terms we take. Plus 12 B1 minus B2L minus 2PL x cubed. Then plus these two terms. 12b2 plus p x in fourth power must be 0. Now this should be correct for all x. Now that means that all these coefficients must be 0. First of all, p, as we see, p from here, from this one, x in fourth power. P equals minus 12b2. If p equals this, then it's okay. Now, if that is the case, let us substitute here. X cubed. 12b1 minus b2l minus 2pl. But that means 2 plus 24 b2l, yes, is 0. Am I right? Please say something. So this minus, but PL is positive then. Now I'm getting here 12 is gone, and this is 2. So will be then B1 equals, look, B2L minus 2B2L. Now this equals what? Minus B2L. B1 must be minus B2L. Now from here, x squared. B0 equals B1L. But B1L equals, that equals minus B2L squared. It's because B1L equals minus B2L. And we are left with the first one. Minus 12b0l plus pl cube equals 0. So b0 equals minus, no, b0 equals plus p l cubed divided by 12l. So that is pl squared over 12. But p equals minus 12b2. So that is minus 12b2. That is L squared divided by 12 minus B2L squared. So what we got? D of x equals B0 plus B1x plus B2x squared, yes? Now this equals B0 equals minus B2L squared. B1 equals minus B2L minus B2LX. And then there is B2. B2x squared. So that means that if d of x equals, let us take here minus b2, minus b2, b2. Then we have L squared plus Lx minus x squared. Then W of x that we talked about. And what is this W? L cube x minus 2L x cubed plus x in fourth power is the mode shape. Comments? What are your comments? If d of x equals this, then W of x is a mode shape. Mr. Andres, your comment. Before that, I want to tell you like this, 13. A Russian person, that is a joke actually. Russian person was asked in 1960. Can you describe the situation in Russia in one word? So his answer was good. Then he was, what about 2 words? He said, not good. Okay? In 1 word, he said, situation is good. In 2 words, he said, situation is not good. But comments, I want 1-word comment. Let us start with 1 word. Improbable. Mr. Gomez. Mr. Penteras. Ms. Gentilini. I'm writing. You can say what you want. 1 word. Good. Are you from Russia? No. Say it again.
I get lost.
You got lost. Why?
Because I went out and so I didn't understand everything.
Okay, if you did not understand everything, you should ask. Ask, please. Okay, before comments, we have questions. Yes, what is your question? Can you speak louder? Because I don't.
What have we done?
What did we do? Okay. we considered a candidate mode shape. We built it, we constructed it. Okay, candidate mode shape. Because this function should satisfy boundary conditions. Then we constructed EI of x, which equals d of x, so that the candidate mode shape became the real mode shape. Okay, we founded that candidate function. There is such d of x that satisfies that d of x together with w. So look, d of x and w of x dance together in the discotheque. And everything works okay. That is what we did. Now, I would like you to, do you have any more questions? No. So let us comment about these questions. I mean, comments. I would like to say that some of the comments are nonsensical. I want you to find which of the comments is nonsensical. At least one is not sensical. Okay, which one is nonsense? Possible, you think is not. Why? Yeah, it's not possible is not a good answer because we already demonstrated. So it is not possible, but it was already done. So you can say possible before we do something, but after you do something, it is not possible or something. There is one more nonsensical. At least when we say one word. Which one is nonsensical? Improbable is also nonsensical because look, we did already. What does it mean it is improbable? We already did. You know, once you win in the lottery, then that is not improbable. That is just a result. And that is a now, out of these two, one is extremely weak. Which one is very weak? Out of these two. Now forget these previous two. Now we will discuss about these two. Which one is a weaker? Mr. Andres. Good is a weaker. Okay, you think so. What do you think, Mr. Panteras? Interesting, of course, is very weak because interesting is almost, no, I don't care about it. I mean, almost about everything you can say interesting. You know, for example, there are some people who even say, today we have an interesting weather, something like that. Now, from the remaining answer, I think that the remaining answer is not very good. Why? why the remaining answer is not very good? It should be replaced by something else. Can you replace it by some other word? Okay, so we said that possible, improbable are not good. Interesting is too weak, really. I mean, it's too neutralistic. You know, I don't care. Like, I don't care about it. Something like that. Now, good is also not very good due to some reason. Why? Look, to say something is good, that is like to go, you know, to the 5-star restaurant and eat unbelievable food, and then you say it is good. It is unbelievable. It is great. That is what we should say, great. Because, look please, I told you that Euler in 1744 gave irrational number, yes? Then Zhanitsyn gave 80I0 over L squared. Then Duncan in 1937 gave 60 over 7 EI0 over L squared. Look, please, 1744, but it is irrational. Then rationality comes actually only in this in past century. 1937, then 1955. And then suddenly, you know, in 2003, I'm talking to you and we find actually something else. Is it good or interesting or improbable or possible? That is just great. It is unbelievable. Do you agree? That is an unbelievable result we obtained, and in few minutes actually, I mean just within 1 hour, more or less. Now let us discuss this issue. You know, very often what happens is as follows, so that, you know, when people come to the universities, they are excited, you know. They want to change the world, they want to deal with big issues. Suddenly, after they start in the university, you know, every day they are getting some interesting results. So they become immune to senses. You see, they become non-responsive human beings, you know, that are not excited, you know, most unfortunately. I would like that we break this pattern. And, you know, if something is excitable, then we should get excited. Are you asleep? Okay. So, but before we comment further, let us discuss some questions, of course, you can have. First of all, one may say, okay, what we can say? I have heard that the operation succeeded, but patient died. You know, there is this sentence, operation succeeded, patient died. Operation was successful. No, they did everything successfully, but patient died at the end. So that is not a successful operation. Is it right? That is a contradiction. Because why I say that? D of x equals minus b2 L squared plus Lx minus x squared. If d of x is negative, then patient died. Is it right? Is it right? Because d of x must be a positive quantity, EI. But I have here minus b2. Minus B2 is really very bad, information. Unless, what should we demand? How to make this patient alive? What if it is positive? B2 must be negative. Yes. B2 must be negative. That is one thing. Because then minus B2 will be a positive quantity. Now, because this function is a positive function, look, L square. Let us look, let me write it down here, and 14. L square plus Lx minus x square. When x equals 0, this equals L square. When x equals L, this equals L square plus L square minus L square is L square. So actually this function is like this. Okay, that is a function. It's a positive function. So it means that B2 must be negative. Now, let us summarize the results. First of all, we got some great results. Second of all, what are the results? D of x equals minus B2 L square plus Lx minus x square. Okay? So B2 is negative, but that means that minus B2 is a positive quantity. So therefore, we can write D of x equals absolute value of B2, L square plus Lx minus x square. Because if B2 is negative, that means that absolute value of B2 will be positive. Now, how much is the buckling load? We had this. P equals minus 12 B2, we said. So that means that, but B2 is negative. Wonderful. Because B2 is negative, so P equals 12 absolute value of B2. So there is just one more question left and we are done. What is this question? One question remains. I want to squeeze it from you. One question. Please get awakened. Open your eyes. If someone will listen to us now later, they will think that you have closed your eyes, but that is not correct.
Why has no one else said?
Then you have to ask others. Oh, yes. Student is asking why others did not find this solution. That is their problem. No, I don't know. Because it's very simple. No one asks these questions. No one asks these questions. But there is one question before we go, because technical question. There is a technical question. Technical question is, what is B2? How much is B2? How much? Answer. That is a question. Any number. Okay, any negative number. Any negative number is okay. So that means that how many solutions we have? How many solutions to our problem? What is an answer? Infinite amount of solutions. You can take any B2. B2 equals -1, -2, -3, -5, -7, -pi if you want. If someone wants pi, it's also okay. Yeah. Yeah, it is in units of EI over L square because, look please, this B2 over L square is EI. B2 over L square has a dimension of EI. Is it right? Because D is EI. Okay? Because L square I can take out, then it will be non-dimensional. From here we see that B2 has a dimension of EI over dimension of L square. It's okay. No, sir, EI over L is not negative. This minus B2 is like this. Minus B2 has a dimension. Minus B2. I should have taken minus here. Minus B2 over L square is dimension of EI. Minus B2 L square is positive. So minus B2 is EI over L square. So everything is okay. Everything just fits. Do you remember? Mr. Kachran, I think. If it does not fit, you must No, there is one word here. Do you remember Mr. Kachran, this lawyer in some case, O.J. Simpson case? He said, if it does not fit, you must acquit. That is what he said. If the glove does not fit, then you must acquit. In our particular case, all fits. Okay, now just the homework. Find a polynomial. Okay, now we have to write more things. 14, 15, 16, 17. Homeworks. Can you find another fourth order polynomial for W of x? I don't know what is an answer, whether one can find or not. I'm just asking you. Then find fifth order polynomial. So now here we take W of x by Duncan and perform this analysis. Okay, this type of analysis. And then find EI equals D of x again by this method. To remember, Duncan guessed. We do not want to guess. We want to have some scientific way of doing things. Now gamma. Take another fifth order polynomial. I know that there are several fifth order polynomial, not Duncan's. And find another d of x and p, of course, yes? So it's very simple. I don't like to give too many homeworks. And I can distribute you the paper that I published in 2001, actually, on this topic, how to find these solutions. Thank you very much.